हेलो स्टूडेंट्स, इस वीडियो में डॉक्टर एस सी वर्मा का बुक कंसेप्ट्स ऑफ फिजिक्स पार्ट 1 का चैप्टर 8 वर्क एंड एनर्जी का प्रॉब्लम्स 6 to 10 का सॉल्यूशंस किया जाएगा, जो कि इस चैप्टर का वीडियो नंबर 2 और पार्ट 2. In this video, I, Abhay Kumar, going to solve the problems number 6 to 10 of the book Concepts of Physics Part 1, written by Dr. S. Verma, of Chapter 8, Work and Energy, for Class 11 Physics, and also for NEET and IIT JEE entrances. First of all, we have to solve problem number 6. A particle moves from a point, position vector, a small r1 vector equals to 2 meter I cap plus 3 meter j cap to another point, position vector, a small r2 vector equals to 3m I cap plus 2m j cap, during which a certain force capital F vector equal to 5 Newton I cap plus 5 Newton j cap acts on it. Find the work done by the force on the particle during the displacement, where I cap is the unit vector along x-axis and j cap is the unit vector along y-axis. A particle को constant force 5 Newton I cap plus 5 Newton j cap अप्लाई कर एक पॉइंट से यहाँ पोजीशन वेक्टर r1 वेक्टर स्मॉल r1 वेक्टर इक्वल टू 2 मीटर I कैप प्लस 3 मीटर j कैप है, वहाँ से दूसरे पॉइंट जिसका पोजीशन वेक्टर r2 इक्वल टू 3m I कैप प्लस 2m 2 मीटर j कैप है. तो उस पार्टिकल को फोर्स 5m I कैप प्लस 5m j कैप द्वारा एक पॉइंट से जिसका पोजीशन वेक्टर दिया है से दूसरे पॉइंट तक डिस्प्लेस किया जाता है, जिसका भी पोजीशन वेक्टर दिया गया है, इसका मैंने जिक्र किया. तो वर्क डन बाय द फोर्स ऑन द पार्टिकल ड्यूरिंग द डिस्प्लेसमेंट. तो इस डिस्प्लेसमेंट में पार्टिकल के एक पॉइंट से दूसरे पॉइंट तक फोर्स अप्लाइड फोर्स के द्वारा डिस्प्लेसमेंट में वर्क डन बाय द फोर्स कैलकुलेट करता है. फोर्स के द्वारा कितना वर्क डन किया गया यह कैलकुलेट करना है. नाउ वी हैव टू सॉल्व इट. फर्स्ट ऑफ ऑल वी हैव टू फाइंड डिस्प्लेसमेंट ऑफ द पार्टिकल. सबसे पहले डिस्प्लेसमेंट मालूम कर लिया जाए. पार्टिकल का एक पॉइंट से दूसरे पॉइंट तक ले जाया गया, फोर्स अप्लाई कर फोर्स के हेल्प से तो कितना डिस्प्लेसमेंट हुआ वो मालूम कर लिया जाए. तो डिस्प्लेसमेंट एस से डिस्प्लेसमेंट एस ऑफ द पार्टिकल इज गिवन बाय एस वेक्टर इक्वल्स टू फाइनल पोजीशन वेक्टर r2 वेक्टर माइनस r1 वेक्टर. दिस इज द डिस्प्लेसमेंट वेक्टर, दैट इज डिस्प्लेसमेंट ऑफ द पार्टिकल व्हेन द पार्टिकल मूव फ्रॉम द फर्स्ट पॉइंट वेयर पोजीशन वेक्टर इज r1 वेक्टर इज गिवन 2m I cap plus 3m j cap to another point with position vector is also given, which is r2 equal to 3m I cap plus 2m j cap. So displacement of the particle is given by s vector is equal to final position vector of the particle minus initial position vector of the particle, that is r2 minus r1, and it is r2 is given 3m I cap, that is 3 I cap plus 2m j cap, that is 2 j cap in meter, minus r1 vector, this is r2 vector, which is 3m I cap plus 2m j cap, minus r1 initial position vector of the particle is 2m I cap plus 3 j cap, that is 2 I cap plus 3 j cap, माइनस आगे में है तो इसलिए माइनस 3 j cap हो जाएगा ब्रैकेट को निकालने पर. तो इट इज r2 displacement of the particle is r2 vector minus r1 vector. It is 3 I cap plus 2 j cap minus 2 I cap minus under bracket 2 I cap plus 3 j cap, and it is after removing the bracket, it is 2 I cap minus 3 j cap. So now we have 3 I cap minus 2 I cap equal to 1 I cap, that is I cap only, plus 2 j cap minus 3 j cap is minus j cap, that is minus 1 j cap, so it is minus j cap. So we have find the displacement of the particle when the particle is displaced from the first point to from a point to another point, that is from the first point to the second point. तो पार्टिकल का डिस्प्लेसमेंट एक पॉइंट से दूसरे पॉइंट तक हुआ, तो डिस्प्लेसमेंट मालूम हो गया कितना, आई कैप माइनस जे कैप. दिस इज द डिस्प्लेसमेंट ऑफ द पार्टिकल. डिस्प्लेसमेंट ऑफ द पार्टिकल. नाउ वर्क डन बाय द फोर्स during this displacement, S vector is equal to I cap minus J cap, and it is given by work done by the force is during this displacement I cap minus J cap is W equals to F vector, the scalar product of force and displacement, that is F vector dot S vector. This is the formula for work. Work is equal to the scalar product of force and displacement, that is F vector dot S vector, and F vector is equal to force applied on the body 5 I cap plus 5 J cap, so it is 5 I cap plus 5 J cap dot force is given in Newton 5 I cap plus 5 J cap, that is 5 I cap plus 5 J cap, and displacement is I cap minus J cap, that is 1 I cap minus 1 J cap, that is I cap minus J cap. Now it is 5 I cap dot I cap minus 5 I को I से स्केलर प्रोडक्ट किया गया, तो 5 I cap dot I cap, 5 I को J cap से मल्टीप्लाई किया जाएगा स्केलर प्रोडक्ट, तो माइनस 5 I माइनस J cap, तो 5 minus 5 it is minus 5 I dot J cap, I cap dot J cap, but I cap dot J cap is 0. A scalar product of two mutually perpendicular unit vectors is 0. I cap is the unit vector along x-axis, and J cap is the unit vector along y-axis. So the scalar product of I cap and J cap is 0. I cap and J cap का scalar product 0 होगा, इसलिए product of 5 I cap into minus product of scalar product of 5 I cap and minus J cap is 0. Now we have to multiply 5 J cap dot I cap. J cap dot I cap is also 0. So now we have to multiply, that is a scalar product of 5 J cap and minus J cap is minus 5 J cap से minus J cap के पहले निगेटिव है, तो मल्टीप्लाई करने पर माइनस 5 इंटू J cap dot J cap, so it is minus 5 J cap dot J cap, I cap dot I cap and J cap dot J cap is 1. A scalar product of similar unit vector, that is same unit vector, that is I and I, J and J, K and K is equal to 1. So we have 5 I cap minus 5 J cap dot J cap, that is 5 into 1 I cap dot I cap is 1 minus 5 J cap dot J cap is also 1, so it is 1 J cap dot J cap is, so 5 into 1, that is 5 minus 5 into 1, that is 5 I minus 5 that is 0. So work done by the force during the displacement of the particle S vector is equal to I cap minus J cap is 0. This is the answer of this problem. Work done by the force during the displacement of the particle I cap minus J cap by the force I cap plus I and J cap is. Now we have to solve problem number 7 of the book Concepts of Physics, chapter 8, Work and Energy. Problem number 7. A man moves on a stationary road with a block of mass 2 kg in his hand. If he covers a distance of 40 meters with an acceleration of 0.5 meter per second square, find the work done by the man on the block during the motion. तो एक आदमी अपने हाथ में 2 kg का मास 2 kg ब्लॉक, 2 kg मास का एक ब्लॉक लेकर, एक बॉडी को लेकर के स्ट्रेट रोड पर, मैन मूव्स ऑन ए स्ट्रेट रोड, दैट इज सीधी सड़क पर चल रहा है, 2 kg का मास लेकर एक आदमी अपने हाथों में। यदि वह आदमी 40 मीटर डिस्टेंस कवर करता है एक्सेलरेशन 0.5 मीटर पर सेकेंड स्क्वायर के साथ, तो फाइंड द वर्क डन बाय द मैन ऑन द ब्लॉक ड्यूरिंग द मोशन। तो आदमी के द्वारा उस ब्लॉक पर उसके मोशन के प्रोसेस में, उसके मोशन के दौरान कितना वर्क डन किया जाएगा वह मालूम करना। तो ब्लॉक का मास 2 kg है, तो ब्लॉक का वेट आदमी उसे अपने हाथ में लिए हुए है, हैंड में लिए हुए है, तो ब्लॉक का मास डाउनवर्ड एक्ट करेगा हाथ पर, जो कि हैंड के रिएक्शन के द्वारा, नॉर्मल रिएक्शन के द्वारा बैलेंस हो जाएगा। और चूँकि ब्लॉक का मोशन आदमी के साथ हो रहा है, इसलिए वर्क डन बाय द फोर्स इज वर्क डन बाय द मैन ऑन द ब्लॉक ड्यूरिंग द मोशन। तो जब आदमी का मोशन हो रहा है स्ट्रेट रोड पर, तो आदमी के द्वारा कितना वर्क डन किया जाएगा ब्लॉक पर अपने मोशन के ड्यूरिंग। तो वर्क डन इक्वल्स टू फोर्स, वर्क डन बाय द मैन ऑन द ब्लॉक इज वर्क डन इक्वल टू फोर्स इंटू डिस्प्लेसमेंट F into S, and F is mass into acceleration multiplied by distance is 40 meter, that is force is equal to m into a, because weight of the block is balanced by the reaction of the hand. So vertical forces are balanced, normal reaction and weight of the block, and so horizontal force is mass of the block multiplied by acceleration. So m into a multiplied by s, and mass of the block is given, it is 2 kg mass. It is 2 kg multiplied by acceleration is 0.5 meter per second square, and displacement distance covered by the man is 40 meter, and block will also cover the same distance 40 meter, because the man moves on the straight road with a block of mass 2 kg in his hands. ये आदमी ब्लॉक को अपने हाथ में लेकर चल रहा है सीधी सड़क पर स्ट्रेट रोड पर, इसलिए आदमी जब डिस्टेंस 40 मीटर तक कवर करेगा तो उस ब्लॉक के द्वारा डिस्टेंस 40 मीटर करेगा, एंड 0 और 40 will cancel out by 0.5 decimal, that is 0.5 is 5 by 10. So now it is 5 into 4, that is 20 into 2, that is 40 joule. Answer. So work done by the man on the block, आदमी के द्वारा ब्लॉक पर किया गया कार्य कितना हो गया, 40 जूल हो गया जब आदमी मोशन कर रहा है ड्यूरिंग द मोशन। Now problem number 8. A force capital F, magnitude of force is given. Capital F is equal to small a plus small b into x. X on a particle in x direction, where small a and small b are constants. Find the work done by this force during a displacement from x is equal to 0 to x is equal to small d. एक फोर्स इसका मैग्नीट्यूड कैपिटल F इक्वल टू स्मॉल a प्लस स्मॉल b x, जो कि किसी पार्टिकल पर x डायरेक्शन में क्रियाशील है, जहाँ a एंड b, स्मॉल a एंड स्मॉल b कॉन्स्टेंट्स हैं। तो फोर्स कैपिटल F इक्वल टू स्मॉल a प्लस स्मॉल b टू x किसी पार्टिकल पर x डायरेक्शन में एक्ट करता है, क्रियाशील है। तो पार्टिकल्स पर तो उस पार्टिकल पर अप्लाई फोर्स F इक्वल्स टू a प्लस bh द्वारा उस पार्टिकल का डिस्प्लेसमेंट 0 से x इक्वल टू 0 से x इक्वल टू d डिस्प्लेसमेंट में वर्क डन बाय दिस फोर्स, बाय द गिवन फोर्स कैलकुलेट करना है। तो गिवन फोर्स कैपिटल F इक्वल टू स्मॉल a प्लस dx द्वारा उस पार्टिकल का डिस्प्लेसमेंट 0 से x इक्वल टू 0 से x इक्वल टू स्मॉल d तक डिस्प्लेसमेंट में वर्क डन बाय द फोर्स कैलकुलेट करना। नाउ वी हैव टू सॉल्व इट। वर्क डन बाय द फोर्स ड्यूरिंग द डिस्प्लेसमेंट फ्रॉम x इक्वल टू 0 to x इक्वल टू d given by the integral w इक्वल टू x इक्वल टू 0 to x इक्वल टू स्मॉल d इंटीग्रल x इक्वल टू 0 to x इक्वल टू स्मॉल d f into dx। Now f is given ax a plus bx, so it is work done by this force is w equals to integration over x equal to 0 to x equal to d. Both are displacements, that is x equal to between the displacement x equal to 0 to x equal to d, we have to calculate work done by the force. So w is equal to integral x equal to 0 to x equal to d f into dx, and there f is given, it is now integral over x equal to 0 to x equal to d. F is given a plus bx, so it is a plus bx multiplied by dx, and now we have w equals to integral over x equal to 0, x equal to 0 to x equal to d, a into dx, it is a into dx, a is constant, so it is taken out of the integration, a constant का integration से बाहर कर लिया जाए, so it is w equal to integral over a is outside the integral in the first term. This integration x equal to 0 to x equal to d will apply on the both terms a and bx, so it will be the sum of two integration now, sum of two integrals now. So first integral is a into dx, and second integral is integral over x equal to 0 to x equal to d dx dx. b is also constant, so b can also be taken out of the integration. b constant है, b को इंटीग्रेशन से बाहर लाया जा सकता है, लेकिन अब फर्स्ट टर्म में a इंटीग्रेशन से बाहर हो गया, तो a को a constant है, इंटीग्रेशन से बाहर किया गया, तो a into integral x equal to 0 to x equal to d dx plus second integral is integral x equal to 0 to x equal to d dx dx. b is also constant, so b is taken out of the integral, so it is b dx. Inside the integral it is, inside the integration it is x into dx, b is taken outside the integral, b constant है, जैसा कि फर्स्ट टर्म में d constant था, उसको भी स्मॉल a को भी इंटीग्रेशन से बाहर किया गया, बाहर रखा गया, तो फर्स्ट टर्म इज a into integral x equal to 0 to x equal to d dx plus second term is, second integration is now integral over x equal to 0 to x equal to d dx dx, and b is also constant, so b is taken out of the integration, b को integration से बाहर किया गया, x into dx integration over x equal to 0 to x equal to d. Now first term is a multiplied by integration of dx is x, and limit is d minus upper limit is x equal to d, lower limit is 0, so it is integration of dx is x, and limit is 0 to lower limit is 0, upper limit upper value of x is d, so it is a multiplied by x, x under bracket lower limit is 0 to upper limit d plus b, and now integration of x dx is x square upon 2, so it is x square upon 2, and limit is lower limit is 0, upper limit is d. Now so integration over integration of x dx, integral over x equal to 0 to x equal to d x square upon 2 under bracket, limit is lower limit is 0, upper limit is 2. Now it is we can write it as first term is a into x, w equals to first term, therefore w work done by force during displacement Gx बराबर 0 to x बराबर d. First term is a multiplied by upper limit minus lower limit. Differential का फॉर्मूला यूज करते हैं dt का फॉर्मूला ऑफ डिफरेंशियल. तो a multiplied by अंडर ब्रैकेट x is replaced by the upper limit, then by the lower limit 0, and between that minus sign is taken. So upper limit a minus lower limit 0, that is d minus 0, that is a into b plus second term is b multiplied by x square by 2 under bracket 0 to b. It is 1 by 2 is taken out of the bracket, so it is 1 by 2 into b, and upper limit is d, so x is replaced by d, x के जगह पर d रखा जाएगा डिफरेंशियल का रूल से. तो b square upper limit minus lower limit, and lower limit is x equal to 0, so b square minus 0 square under bracket is b square, so it is half bd square. So what done by the given force is small a into d plus half bd square, and we can take d common. d is present in both terms, क्योंकि d दोनों टर्म्स में प्रेजेंट है इसलिए d को कॉमन किया जा सकता है दोनों टर्म्स में. so we have under bracket a plus 1 by 2 bt small b into small d, and out of the bracket small d there is multiplied by a small d, because d is present in both terms, so d is taken as common. So work done by the given force F equals to a small a plus a small b, this is under bracket small a plus 1 by 2 bd bracket close multiplied by a small d out of the bracket, taking d as common. Answer. This is work done by this force, that is the given force. Now we have to solve problem number 9 of chapter 8 book Concept of Physics part 1, written by Dr. Problem 9 is a block of mass 250 gram slides down an incline, that is inclined plane of inclination 37 degree with a uniform speed. Find the work done against the friction as the block slides through 1 meter. एक ब्लॉक है जिसका मास 250 kg है. m is given, mass of the block is 250 gram, that is 250 upon 1000 kg. ग्राम को केजी में कन्वर्ट किया जाए तो ग्राम को केजी में कन्वर्ट करने के लिए 250 ग्राम है, दैट इज 250 अपॉन 1000 केजी, दैट इज 250 मल्टीप्लाइड बाई 10 to the power minus 3 kg, दैट इज 0.25 kg. It is 0.25 kg. 0.25. 250 gram is 250 into 10 to the power minus 3 kg, that is 0.25. Inclination of the inclined plane is 37 degree from the horizontal. एक ब्लॉक है, बॉडी है जिसका मास 250 ग्राम है और वह स्लाइड कर रहा है डाउनवर्ड विथ यूनिफॉर्म स्पीड. यूनिफॉर्म स्पीड से ब्लॉक इंक्लाइन प्लेन पर पुट किया जाए. इंक्लाइन प्लेन ये भी है और इस पर 250 ग्राम का बॉडी डाउनवर्ड डायरेक्शन में कॉन्स्टेंट यूनिफॉर्म स्पीड के साथ स्लाइड कर रहा है डाउनवर्ड डायरेक्शन में. क्योंकि स्पीड यूनिफॉर्म है तो ब्लॉक का एक्सीलरेशन 0 होगा. सो रिजल्टेंट फोर्स एक्टिंग, रिजल्टेंट डाउनवर्ड फोर्स acting on the block will be reactant force will be 0, and reactant force will act on the block in the downward direction, but since block is moving with constant speed, so acceleration is 0, therefore reactant force using Newton's second law of motion is also equal to 0. So we have weight of the block, that is mg, that is 250 into 10 to the power 0.25 into g. 250 gram is 0.25 kg. So weight of the block 0.25 g, small g is acceleration due to gravity, that is mg will act vertically downward, which is mg, m is 250 gram, that is 0.25 g. And one component of weight balances the one component of weight balance is balanced by the normal reaction of the incline, and it is also 37. That is other component of the force is mg cos 37. Mass is 0.25 kg, and it will be balanced by the normal reaction of the incline, and downward component of force, that is downward component of weight mg sin theta acts along the incline in the downward direction, due to which the body moves with constant uniform speed, and friction force between the block and incline will oppose the downward motion of the block over the incline, so it will act up along the incline, and F equals to mu into N. This is the friction force. Since the body moves downward with constant speed, so resultant downward force is 0. So we have resultant force is mg sin theta minus mu N, which is the friction force between the block and the incline will be 0. Therefore, mg sin theta is equal to mu N. So we have mg sin theta equals to mu N, and normal reaction of the incline balances the vertical component of the weight mg cos 37. So n is equal to, this is equation 1, mg sin theta equals to mu N, because the speed of the block is 0, that is acceleration of the block is 0. Since acceleration of the block is 0, so resultant force acting on the block is also 0. And block is moving down with uniform speed, so acceleration is 0, so resultant force is 0. Therefore, mg sin theta, that is component of the weight of the block along the incline in the downward direction, equals to friction force acting between the block and the incline. तो ब्लॉक पर जो वेट का डाउनवर्ड कंपोनेंट होगा जी साइन थीटा m is given 250 ग्राम, दैट इज 0.25 kg. तो क्योंकि ब्लॉक यूनिफॉर्म स्पीड से डाउनवर्ड डायरेक्शन में मूव कर रहा है, इसलिए एक्सीलरेशन 0 है, इसलिए रिजल्टेंट फोर्स भी 0 हो जाएगा, mg sin थीटा माइनस mu N इक्वल टू 0. देयरफॉर mg sin थीटा इक्वल टू द फ्रिक्शन फोर्स F, and it is mu N. Mu N is the friction force between the block and the incline. So now we have to find work done against the friction as the block slides through 1 meter. So displacement of the block on the over the inclined plane is 1 meter. 1 meter. Block slide down 1 meter on the incline, over the incline. So S is equal to displacement of the block is 1 meter. So work done by the force. Work done against the force of friction is W is equal to Fs, as W is equal to friction force F multiplied by S, and F is mu N. Friction force is equal to mu N, and mu N is equal to mg sin theta. Mg sin theta, that is mg sin 37. Because the inclination of the incline to the horizontal is 37 degree, so it is mg sin 37 degree. The depth friction force is equal to mu N, and mu N is equal to mg sin 37 degree multiplied by S. Now mass of the block is 250 gram, that is 0.25 kg multiplied by G is 9.8. Sin 37 is 3 by 5 multiplied by displacement of the block is 1 meter, and it is 5 will cancel out 0.25 will cancel out by 5 as 0.05. 0.05 multiplied by 5 is 0.25. Numerator में 0.05 multiplied by 9.8 multiplied by 3. So it is 0.05 multiplied by 3 is 0.15 multiplied by 9.8. अब तो अगर मल्टीप्लाई कर दिया जाए 9.8 multiplied by 0.15, we will get the result, that is 8 into 5 centimeters, 9 into 5, 45 plus 4, 49, 8 into 1, 8, 9 into 1, 9, and it is 0, 9 plus 8, 17, रिमाइंडर 1 9 plus 4 plus 1 14 and it is decimal 3 place पर है तो 1.470 it is 1.470 it is work done by the force work done against the frictional force is W equals to 1.470 that is 1.470 and it is approximately equal to 1.52 answer work done against the frictional force to as the block slides down 1 meter over the incline the block incline plane पर 1 मीटर नीचे की ओर स्लाइड करता है उस इंक्लाइन प्लेन पर जिसका हॉरिजॉन्टल से इंक्लिनेशन दिया है 37 डिग्री तो वर्क डन अगेंस्ट द फ्रिक्शन फोर्स इज W इक्वल्स टू फ्रिक्शन फोर्स F into S and friction force is equal to F equal to nu into N and it is equal to mg sin 37 in place of friction force we have we can write mg sin 37 into S. This is the displacement of the block which is 1 meter. After calculation we get W equals to 1.470 which is approximately nearly equal to 1.5. This is the solution of this problem number 9 of chapter 8 SC Verma book What can you help? Now we have to solve problem number 10 which is a block of mass small m is kept over another block of mass capital M and the system rests on a horizontal surface which is shown in figure 8g1 given in the book. A constant horizontal force capital F acting on the lower block of mass capital M in the figure produces an acceleration a small a equals to capital F upon 2 a small 2 under bracket a small m plus capital M bracket closed in the system. System means combination of that is two masses capital M and a small m taken together form a system. Part A, find the coefficient of kinetic friction between the bigger block of mass capital M and the horizontal surface. Part B, find the frictional force acting on the smaller block of mass small m. And part C, find the work done by the force of friction on the smaller block of mass small m by the bigger block of mass capital M over which the smaller mass is kept. The smaller mass of mass small m is kept over the bigger block of mass capital. So part C, find the work done by the force of friction on the smaller block by the bigger block during a displacement a small d of the system. एक ब्लॉक है जिसका मास स्मॉल m है और वह एक दूसरे ब्लॉक जिसका मास कैपिटल M है उस पर रखा गया है एंड बोथ मासेस स्मॉल m एंड कैपिटल M फॉर्म ए सिस्टम. स्मॉल m मास को एक हॉरिजॉन्टल सरफेस पर रखा गया है जिसे फिगर 8g1 में रिप्रेजेंट किया गया है. जो फिगर मास है जिसका मास कैपिटल M है जो कि हॉरिजॉन्टल सरफेस पर रखा गया है उस पर एक हॉरिजॉन्टल फोर्स कैपिटल F अप्लाई किया जाता है जिसके कारण इस सिस्टम में दैट इज सिस्टम मीन्स व्हेन बोथ ब्लॉक्स ऑफ मासेस कैपिटल M एंड स्मॉल m टेकन टुगेदर तो सिस्टम में एक्सेलरेशन प्रोड्यूस होता है स्मॉल इक्वल्स टू कैपिटल F अपॉन 2 अंडर ब्रैकेट स्मॉल m प्लस कैपिटल M. दिस इज द एक्सेलरेशन ऑफ द सिस्टम बिकॉज both blocks move together so there will be common acceleration of the system. क्योंकि दोनों ब्लॉक एक साथ मूव कर रहा है कांस्टेंट फोर्स एक फोर्स अप्लाई किया जाता है लोअर ब्लॉक पर मतलब जो हेवियर मास है उस पर कैपिटल F. इसके साथ बोथ ब्लॉक्स एक साथ मूव करता है मतलब बोथ ब्लॉक्स का एक्सेलरेशन कॉमन होगा एंड दैट कॉमन एक्सेलरेशन इज गिवन स्मॉल इक्वल्स टू कैपिटल F अपॉन 2 under bracket a small m plus capital M, and suppose it is equation is to find. We have to find in part A. We have to find the coefficient of kinetic friction between the bigger block and the horizontal surface. Coefficient of kinetic friction between the bigger block and the horizontal surface. Horizontal surface and bigger block के बीच coefficient of friction मालूम करना है. And part B में find the friction force acting on the smaller block. और smaller block small m पर कितना फ्रिक्शनल फोर्स एक्ट करेगा और मालूम करना है. Part C में find the work done by the force of friction on the smaller block by the bigger block during a displacement small d of the C. And part C में work done by the force of friction. Friction force के द्वारा work done by the force of friction on the smaller block by the bigger block. Bigger block जिसका मास कैपिटल M है उसके द्वारा स्मॉलर m मास के ब्लॉक पर जो फ्रिक्शन फोर्स वर्क करेगा, एक्ट करेगा, उसके द्वारा सिस्टम के डी डिस्प्लेसमेंट, स्मॉल डी से सिस्टम जब मूव करेगा उसके लिए उस सिचुएशन में वर्क डन बाय द फोर्स ऑफ फ्रिक्शन ऑन द स्मॉलर ब्लॉक बाय द बिगर ब्लॉक. बिगर ब्लॉक के द्वारा स्मॉलर ब्लॉक पर वर्क डन बाय द फोर्स ऑफ फ्रिक्शन मालूम करना. तो जब हॉरिजॉन्टल फोर्स जब एक हॉरिजॉन्टल फोर्स बिगर मास पर या बिगर मास जिसका दैट इज जो बड़ा ब्लॉक है, बी ब्लॉक है, जिसका मास जो बड़ा ब्लॉक है जिसका मास कैपिटल है उस पर हॉरिजॉन्टल फोर्स अप्लाई किया जाता है. तो उस सिचुएशन में जो कि लोअर ब्लॉक भी है कैपिटल एन मास का, इस पर जब एक फोर्स अप्लाई किया जाएगा, कैपिटल एफ व्हिच फोर्स इज अप्लाइड ऑन द लोअर ब्लॉक, then the smaller block of mass small m tends to move towards left due to inertia. जब कैपिटल एफ फोर्स अप्लाई किया जाता है लोअर ब्लॉक पर जिसका मास कैपिटल एम है, जिसे हॉरिजॉन्टल सरफेस पर रखा गया है, तो इनर्शिया के कारण स्मॉल एम मास इनर्शिया के कारण मूव करना चाहेगा अपोजिट डायरेक्शन. तो इस ब्लॉक को, स्मॉल एम मास के ब्लॉक को कैपिटल एम मास के ब्लॉक पर रखने के लिए, क्योंकि सिस्टम बोथ ब्लॉक्स सिस्टम एक साथ मोशन करता है तो दोनों का कॉमन एक्सीलरेशन होगा. तो क्योंकि स्मॉल एम मास टेंड करता है, कोशिश करेगा लेफ्ट डायरेक्शन में मूव करने का ड्यू टू इनर्शिया, जब कैपिटल एफ फोर्स लोअर ब्लॉक पर अप्लाई किया जाता है, तो स्मॉल एम मास को इस ब्लॉक मतलब जो लोअर मास है और बिगर मास है जिसका मास कैपिटल एम उस पर रखने के लिए बिगर मास के द्वारा फ्रिक्शन फोर्स अप्लाई किया जाएगा फॉरवर्ड डायरेक्शन, एंड दैट फ्रिक्शन फोर्स इज फोर्स ऑफ फ्रिक्शन एफ इक्वल्स टू म्यू के इनटू दैट इज काइनेटिक फ्रिक्शन, कोएफिशिएंट ऑफ काइनेटिक फ्रिक्शन इज म्यू के इनटू एन, and n is equal to n. Mass of the block, if we take free body diagram, then mass of the smaller block, that is which is the small m, that is weight of the block hits vertically downward, W is equal to mg, and normal reaction of the lower block of mass capital M will act vertically upward, and which balances the weight of the mass small m, that is a smaller mass. So for the motion of the system together, friction force on the smaller mass small m, a smaller block of mass small m will act towards right. So for the motion of block of mass small m, we have F equal to force of friction, kinetic friction, F equal to, or F equal to mu k into n. Mu k is the coefficient of kinetic friction, and n balances the weight of the block. So mu k into mg, n is equal to mg, and F equal to, since the system moves with constant moves with common acceleration A, so acceleration of mass small m and the capital M will be the same. So it is F equal to mass into acceleration m into a equals to mu k into mg, and m will cancel out, so it is a equals to small a acceleration equal to mu k into g. Therefore, we have to find the coefficient of kinetic friction between the bigger block and the horizontal surface. So, coefficient of kinetic friction is mu k equals to a upon g, and acceleration of the system is given, small a is given, small a is given capital F upon 2, small m plus capital F. So, it is small a is capital F upon 2 small m plus capital M multiplied by g, and this is the coefficient of kinetic friction between the bigger block and the surface. This is the answer. Coefficient of kinetic friction is denoted by the symbol mu. Coefficient of kinetic friction. Now, a smaller mass will also act an equal and opposite force of friction according to Newton's third law of motion, which will equal to F is equal to mu k into n between the surfaces of the block of small m, block of mass small m, which is kept over the bigger block or the lower block of mass capital M. So, small mass will also apply the frictional force, which is equal to F equals to, again it is mu k into n. Since the block, since the force F is applied on the lower block and the system moves with common acceleration towards right. So, to keep the block of mass small m over the lower block, the lower block will apply a force of friction, that is kinetic friction, on the smaller mass in the right direction, because a smaller mass tends to move towards left due to inertia, and the upper mass, that is the block of mass small m, will also apply force of friction, that is frictional force mu k into n, according to Newton's third law of motion, in the towards left when the system moves towards right, that is force, capital F force is applied on the lower block. So, we have find the coefficient of kinetic friction between the surfaces, which is mu k equal to a upon small a acceleration by g, with the help of relation small a acceleration of the block over the horizontal surface. We know it is mu k into g. We have calculated it. We have obtained it. So, a equal to mu k, acceleration of the block over a rough horizontal surface is a equal to mu k into g. Therefore, coefficient of kinetic friction between the block and the surface is mu k equal to a small a upon g, and small a acceleration of the system block is given f upon 2 small m plus capital M multiplied by g in the denominator, and this is the answer of this problem. Now, we have to find the frictional force acting on the smaller block, that is F equal to mu k into n by the bigger block, that is the lower block capital F m, which is given by small f equal to mu k into n, which is represented in the diagram. So, we can easily obtain the value of frictional force acting on the smaller block of mass small m, which is a small f equal to mu k into n, and n is equal to n is balanced by the normal reaction of the bigger block on the smaller block, which acts vertically upward. This is an normal reaction, and it will balance by the weight of the block, smaller block, which is W equal to mg. Normal reaction of the surface of the bigger block, which acts vertically upward, balances the weight of the smaller block. बिगर ब्लॉक के द्वारा जो रिएक्शन फोर्स एक्ट करेगा स्मॉलर मास इसका मास स्मॉल m है, वह स्मॉलर मास के वेट को क्या कर लेगा, बैलेंस कर लेगा। n इक्वल टू नाउ आंसर ऑफ पार्ट B that is frictional force acting on the part B. Write down part B, frictional force. Frictional force acting on the smaller block of mass small m by the frictional force acting on the smaller block mass small m by the bigger block is equal to A F, that is F k, or F is equal to mu k into n, which is represented in this diagram. बिगर मास स्मॉलर मास को, जिससे कि स्मॉल मास भी बिगर मास के साथ मूव कर सके एक साथ कॉमन एक्सीलरेशन से, क्योंकि स्मॉलर मास लेफ्ट डायरेक्शन में इनर्शिया के कारण मूव करने का प्रयास करेगा, जब बिगर ब्लॉक पर और लोअर ब्लॉक पर हॉरिजॉन्टल फोर्स अप्लाई किया जाएगा हॉरिजॉन्टल डायरेक्शन में उसी। तो स्मॉल एम मास कैपिटल ए मास के सरफेस पर मैंने स्मॉलर मास बिगर मास के सरफेस को स्किप नहीं करे। स्मॉलर मास स्मॉल एम भी बिगर मास कैपिटल एम के सरफेस पर एक साथ टुगेदर मूव करे कॉमन एक्सीलरेशन से। तो उसके लिए बिगर मास दैट इज लोअर ब्लॉक ऑफ मास कैपिटल एम विल अप्लाई a frictional force on the smaller mass small m in the right direction, and the smaller mass will also apply an equal and opposite force according to Newton's third law of motion on the bigger block of mass capital M, which is also equal to mu k. So frictional force acting on the smaller mass of mass small m into bigger mass of mass capital M is equal to mu k into n, and mu k is we have obtained mu k, coefficient of static friction equals to small a upon g. Mu k is equal to acceleration of the system, both blocks upon acceleration due to gravity, by using the formula a is equal to acceleration of a block over the horizontal surface, a is equal to mu k into g. Therefore mu k is equal to a upon g, and it is f upon 2 under bracket the small m plus capital M multiplied by g. We have obtained in part a. In the solution of part a, suppose it is equation number 1. So in place of mu k we can write capital F upon 2 small m plus capital M multiplied by g. This is the value of mu k, and m is equal to normal reaction of the surface of bigger block of mass capital M is capital N, which balances the weight of the smaller block of mass small m, that is m. So n is equal to m. So in place of n we can write a small m weight of the smaller block. G and g in the denominator will cancel out. So we will left with friction force acting on the smaller block or upper block of mass small m due to the lower block or bigger block, and it is F equals to frictional force equals to it is F upon 2 multiplied by under bracket small m plus capital M multiplied by in the numerator which is small m, and this is the answer of part B, that is friction force acting on the smaller block of mass small m due to the bigger block. The small m is equal to capital F upon 2 under bracket the small m plus capital M, that is mass of both blocks multiplied by small m in the numerator, which is the mass of the smaller block. Now we have to find the work done by the force of friction on the smaller block by the bigger block during a displacement small d of the system. So work done by the force of friction on the smaller block by the bigger block during a displacement small d of the system. जब इस सिस्टम का मतलब बहुत मासेस का डिस्प्लेसमेंट डी होता है, स्मॉल डी से होता है, तो उस इक्वेशन में बिगर ब्लॉक के द्वारा स्मॉलेस्ट ब्लॉक पर जो फ्रिक्शन फोर्स एक्ट करेगा स्मॉल एफ इक्वल टू कैपिटल एफ अपॉन 2 अंडर ब्रैकेट स्मॉल एम प्लस कैपिटल एम इनटू मल्टीप्लाई बाई स्मॉल एम इन द न्यूमरेटर. तो इस फ्रिक्शन फोर्स के द्वारा जितना वर्क डन होगा स्मॉल डिस्प्लेसमेंट में सिस्टम का वो हम मालूम करता है. So work done by the friction force is given by friction force F multiplied by displacement D. So we will get the result. So work done by the friction force on the smaller block of mass small m due to bigger block given by W equal to F multiplied by D displacement D, and F we have obtained in part B. Friction force acting on the smaller block of mass small m due to the bigger block or lower block of mass capital M, which is small f equal to capital M into small m is the friction force equal to capital M F upon 2 under bracket small m plus capital M multiplied by a small m in the numerator. Multiplication is small m in the numerator Fm upon 2 small m plus capital M. So it is in place of F we can write F into M upon 2 small m into plus capital M multiplied by displacement D, and this is the result that is work done by the friction force on the smaller mass small m due to the bigger mass for displacement of small d of the system, which is W equal to friction force small m into d multiplied by small d, and the friction force is small f equal to capital M into a capital M upon a small m upon 2 under bracket a small m plus capital M multiplied by a small d, which is the displacement of the system. And this is the answer of this part C of this problem number 10. Now this video is completed. अभी यह वीडियो पूरा होता है. Thanks all of you for watching my YouTube channel.